Dear 11th standard students, today we are going to see the important topic center of mass of the 2-point masses of the system. Let us consider 2-point mass. M1 is one of the point mass, M2 is the another point mass. How we calculate the center of mass of the 2-point mass of the system? There are three ways there to determine the center of mass of the 2-point masses of the system. First one method, when these 2-point masses is located along the positive x-axis, it is one of the easy way to determine the center of mass of the 2-point masses of the system. First we are consider the coordinate system. When the masses are placed on the x-axis, this is one of the way to determine the center of mass of the 2-point masses of the system. First we assume coordinate system. In the coordinate system, first we choose origin of the coordinate system O. X-axis, positive x-axis, negative x-axis, positive y-axis, negative y-axis. These 2-point masses is located on the positive x-axis. M1 is one of the point mass, M2 is the another 2-point mass. These 2-point masses are placed along the positive x-axis. But in our aim to determine the center of mass of the 2-point masses of the system, x1 is the position of the first point mass M1 from the origin. X2 is the position of the second point mass M2 from the origin, or simply we call x1 is the distance of the first point mass from the origin, x2 is the distance of the second point mass M2 from the origin. It is also called x1 is the position of the first point mass from the origin, x2 is the position of the second point mass from the origin. Then how we find out the center of mass of the 2-point masses of the system? By using one calculation. We have a equation. Center of mass point of the 2-point masses is also lying along the positive x-axis by the equation m1x1 plus m2x2 divided by m1 plus m2. This is an equation to calculate the center of mass of the 2-point masses of the system if the 2-point masses are lying or located along the positive x-axis. So, center of mass of the 2-point masses of the system is also lying along the positive x-axis. This is center of mass point, is also lying along the positive x-axis. So, XEM is the position of the center of mass point of the 2-point masses of the system from the origin. That is the equation XEM. CM represents the center of mass of the 2-point masses of the system, which is equal to m1x1 plus m2x2 divided by m1 plus m2. Already we know that x1, x2, m1, m2, we can easily find the position of the center of mass point of the 2-point masses of the system. It is one of the way to find out the center of mass point of the 2-point masses of the system when the masses are placed on the x-axis. Second way to find out the center of mass point of the 2 point masses of the system. When the origin is coincide any one of the point mass. This is a second way to determine the center of mass of the 2 point masses of the system. See, origin is coincide with the any one of the point mass. First we choose the coordinate system. Origin of the coordinate system O. Positive x-axis, negative x-axis, positive y-axis, negative y-axis. So origin is coincide any one of the point mass. Out of 2 point masses, m1 and m2, we choose any one of the point mass is made to coincide with the origin. I assume m1 point mass is made to coincide with the origin. This is m2 point mass is lying along the positive x-axis. Here x1 which is equal to 0. x2 is the position of the second point mass from the origin, but the position of the first mass is made to coincide with the origin position of the first point mass x1 which is equal to 0. X2 is the position of the second point mass from the origin. Then how to calculate the center of mass of the 2 point masses m1 and m2 can be calculated by this equation XEM which is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Here x1 is equal to 0. Substitute within this equation center of mass of the 2 point masses of the system XEM which is equal to m1 x1 value 0 plus m2 x2 divided by m1 plus m2. Then XEM which is equal to m2 x2 divided by m1 plus m2. So this is the position of the center of mass point of the 2 point masses of the system. Center of mass point. So in this case also, center of mass point is lying along the positive x-axis. XEM represents the center of mass point of the 2 point masses of the system which is equal to m2 x2 divided by m1 plus m2. So here first point mass is made to coincide with the origin, but the second point mass is located along the positive x-axis. So position of the first point mass which is equal to 0, then x2 is the position of the second point mass. Then how to calculate the center of mass point of the 2 point masses of the system? By using XEM which is equal to m2 x2 divided by m1 plus m2. Next, another third way to determine the center of mass point of the 2 point masses of the system. When the center of mass point coincide with the origin. This is a third way to determine the center of mass point of the 2 point masses of the system. First we assume coordinate system. Origin of the Cartesian coordinate system O, positive x-axis, negative x-axis, positive y-axis, negative y-axis. Center of mass point of the 2 point masses is made to coincide with the origin. This is center of mass point. So M1 mass is located on the negative x-axis. M2 mass is located along the positive x-axis. X1 is the position of the first point mass from the origin. It is lying along the negative x-axis. That's why that position is taken as negative. Then X2 is the position of the second point mass from the origin. It is taken as positive because that point mass is lying along the positive x-axis. Then how to determine the center of mass point of the 2 point masses of the system? By using this equation XEM, which is equal to M1 x1 plus M2 x2 divided by M1 plus M2. So here center of mass point of the 2 point masses is made to coincide with the origin. That center of mass point XEM, which is equal to 0. So therefore substitute here 0, which is equal to M1, x1 value is minus x1 plus M2 x2 divided by M1 plus M2. So therefore 0 multiplied with M1 plus M2, which is equal to minus M1 x1 plus M2 x2. So this is 0 multiplied with anything 0, which is equal to minus M1 x1 plus M2 x2. Then see the same equation M1 x1, which is equal to M2 x2. This equation is called principle of moments, or this equation is known as principle of moments. So see the students, we assume there are 2 point mass. How to determine the center of mass point of the 2 point masses? There are 3 ways to determine the center of mass of the 2 point masses. One is the 2 point masses is lying along the positive x-axis. Then it is possible to determine the center of mass of the 2 point masses. Then another one is, out of 2 point masses, any one of the point mass is made to coincide with the origin. Then it is an easy way to determine the center of mass point of your 2 point masses. Another one, that is a third way, when the center of mass point of the 2 point masses is made to coincide with the origin, it is possible to determine the center of mass point of the 2 point masses of the system. So, dear students, already we finished the center of mass of the 2 point mass of the system. Already you know about there are 3 ways to determine the center of mass of the 2 point masses. On the basis of the topic, we are going to solve the few problems. See the first problem, example 5.1, 2 point masses 3 kg and 5 kg. First one point mass M1, second one point mass M2, which is equal to 5 kg, are at 4 meter and 8 meter from the origin on the x-axis. These 2 point masses is located on the positive x-axis. 3 kg mass is located on the x-axis from the origin 4 meter, that is x1. 5 kg mass is located on the positive x-axis from the origin 8 meter, which is equal to x2. Locate the position of center of mass. We are going to calculate position of the center of mass of the 2 point masses. First one from the origin, second one from the 3 kg mass. Take first division. from the origin. Calculating the center of mass point. First, we assuming the Cartesian coordinate system. Origin of the Cartesian coordinate system O, positive x-axis, negative x-axis, positive y-axis, negative y-axis. 2 point masses, one is 3 kg, m1 point mass, is located on the x-axis 4 meter distance from the origin. m1, 4 meter distance from the origin. Then second point mass m2 5 kg is located 8 meter distance from the origin. Then how to calculate the position of center of mass point of the 2 point masses? This is center of mass point. What is the XEM? Already we know that the equation XEM, which is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Given data, m1 which is equal to 3 kg, m2 which is equal to 5 kg, x1 is equal to 4 meter, x2 which is equal to 8 meter. Then calculate the position of center of mass point of the 2 point masses. All this data is substituted in this equation. XEM which is equal to m1 value 3 into x1 value 4 plus m2 value 5 into x2 value 8 divided by m1 value 3 plus m2 value 5. So XEM which is equal to 3 into 4, 12 plus 5 into 8, 40 divided by 3 plus 5, 8. XEM which is equal to 52 divided by 8, which is equal to 6.5 meter. So XEM which is equal to 6.5 meters. So see the students, these 2 point masses is located on the positive x-axis. Center of mass point of the 2 point masses is 6.5 meter from the origin. From this origin, that center of mass point lies exactly 6.5 meter from the origin. We finished the first one. Then we are going to calculate the center of mass point from the 3 kg mass. That is easily calculated from the same diagram. Center of mass point of the 2 point masses, the distance is 6.5 meter from the origin. Then from the 3 kg mass, how much distance of the center of mass point is located from the first point mass, which is equal to 3 kg. So total distance of the center of mass point is 6.5 meter. Second, position of center of mass point from the 3 kg mass, which is equal to center of mass point lies from the origin, which is equal to 6.5 meter, minus distance of the first point mass from the origin, which is equal to 4 meter. So subtract this 2.5 meter. So this is the position of center of mass point from the 3 kg mass is 2.5 meter. Or in the same second division, it can be calculated in the another way. We choose the Cartesian coordinate system. Origin of the Cartesian coordinate system O. First point mass is made to coincide with the origin M1, which is equal to 3 kg. Then M2, which is equal to 5 kg. See the students, in the origin of the coordinate system is shifted to first point mass, then the origin is covered a distance 4 meter, then the distance of the second point mass already 8 meter, but that origin is shifted by the 4 meter, then the distance of the second point mass is now 4 meter. First point mass is made to coincide with the origin of the coordinate system. Here x1 which is equal to 0, but the position of the second point mass 5 kg, x2 which is equal to 4 meter. Then how to calculate the position of the center of mass point of the 2 point masses? XEM, which is equal to m1 x1 plus m2 x2 divided by m1 plus m2. So here position of the center of mass point, which is equal to m1 value 3 kg, x1 value 0 because origin is coincide with the first point mass, plus m2 which is equal to 5 kg, distance of the second point mass from the origin 4 meter, divided by m1 value 3 plus m2 value 5. The XEM which is equal to 0 plus 20 divided by 8. So XEM which is equal to 20 divided by 8, 2.5 meter. So it is another way to determine the position of the center of mass point of the 2 point masses from the 3 kg mass. 2.5 meter center of mass point. See the students, now we see the another one important problem related to the center of mass point. The position vector of the 2 point masses, 10 kg is one of the point mass, 5 kg is another point mass, are located minus 3i plus 2j plus 4k is r1 vector, and 3i cap plus 6j cap plus 5k cap is r2 vector measured in meter. Locate the position of the center of mass point. Given data, mass m1 point mass 10 kg, m2 point mass 5 kg, r1 vector which is equal to minus 3i cap plus 2j cap plus 4k cap, r2 vector which is equal to 3i cap plus 6j cap plus 5k cap. How to determine the center of mass point? So RCM which is equal to m1 r1 vector plus m2 r2 vector divided by m1 plus m2. In the three-dimensional Cartesian coordinate system, we locate the position of the center of mass point in space. So RCM vector which is equal to m1 value 10, r1 vector minus 3i cap plus 2j cap plus 4k cap plus m2 5 kg, r2 vector 3i cap plus 6j cap plus 5k cap. divide by 10 plus 5. So position of center of mass point 10 into 3 minus 30 I cap plus 20 j cap plus 40 k cap plus 15 I cap plus 30 j cap plus 25 k cap divided by 15. So position of center of mass point minus 30 I cap plus 15 I cap. So minus 15 I cap, 20 j cap plus 30 j cap plus 50 j cap, then 40 k cap, 25 k cap. So 65 k cap divided by 15. Then position of center of mass point RCM vector, which is equal to minus 15 I cap divided by 15 plus 50 j cap divided by 15 plus 65 k cap divided by 15. 1, 3, 10, 3, 1, 12. So position of center of mass point minus I cap plus 10 divided by 3 j cap to 13 k cap divided by 3. So it is the position of center of mass point in three-dimensional space. So see students, already we completed how to determine the center of mass point of your two-point masses. On the basis of center of mass point of your two-point masses, we solved two problems. So you watched clearly and you gained the knowledge about center of mass point of your two-point masses. Thank you, students.